Okay, so now we'll talk about geometric sequences in series and infinite geometric sequences in series. So in this first example, again, we're looking to find the sum of a series, and you can double check, because if you didn't have this right up above, you wouldn't know that it's geometric until you check. So we can't add the same thing each time, but we can multiply. So we can multiply by 2 to get from 1/4 to 2/4, and then to 2 squared, 2 cubed, etc., always over 4. So that's our common ratio, 2. And so then other pieces from our formulas up here that we know the initial term, a sub 1. And then we have this last term in terms of a. Okay, or I'm sorry, in terms of n. And so that's our a sub n. So we actually already have our formula. And if you take a look, we've got 2 to the n minus 1 over 4. That's not quite in the same format, but we can pull the 1/4 out, and then we can see, okay, there's our a sub 1 from over here, and then we have 2 to the n minus 1, r to the n minus 1, and r is 2. So it fits our formula anyway. And we could have come up with that just based on the a sub 1 and the r. So now we're looking for the sum here. So we're looking at this. We know our first term, we know r. Well, we've got n as n in here. And that's okay. We can leave it as n. So that's the formula we're going to use, our sum formula. And pardon the ginormous multiplication symbol. And so we can plug everything in, and still we can use n, and that's perfectly fine. We'll just simplify, and we'll leave our formula with n. Next, we're looking for another sum. Remember, this is our summation notation. And so this is telling us we're going to start at 1, and we're going to do 15 of these. So we know a couple of pieces of information, but what we might not necessarily know is the r. And so we can test that out. What we can do is we can look for the first term and then the second term. And because this is not linear, because it's exponential, we know it's geometric. And so then that'll tell us our r value. Okay, so we can find the first term and the second term. Then to get from one to the next, you have to multiply by 2/3. So that's how we know that r is 2/3. So now we've got a lot to go on, right? We've got a sub 1, we've got r, we've got n, so we're ready to go. Okay, so we're going to use our sum formula again and go ahead and plug everything in. Now it's a question of simplifying. So if you really want to go wild, you can write it as a fraction. Otherwise, chances are you'll write it as a decimal, an approximation. Okay, so notice we've got essentially the same formula here. Right? We've got 2/3 to the n, starting at 1 and ending at 15. Now we're starting at 1 and ending at n. But we already know a sub 1, r, and n. This time n is n rather than a number. And that's okay because we'll just leave it in the formula. So same formula. Plugging in now, we do have to simplify. Okay, and then we can keep on going. And then remembering our order of operations, that's as far as we can take this. We can't go any further. All right, you'll notice your next example, same little formula here, but now we're going to infinity instead of to n. So when n is there, it means you're going to write a formula. When you have infinity, that means it's an infinite geometric series. So we're using this infinite formula. So here's what we know, but in this formula, all we need is a sub 1 and r. We don't need the n anymore because we're losing that. We're going on and on forever. So there's the formula that we're going to use, and then we'll go ahead and substitute in. And we're trying to see, what number will this converge to? Now the key here is r in absolute value has to be less than 1 in order for it to converge. Otherwise, we'll say that it diverges. Our r is 2/3, which is less than 1, so it will converge. So you will sometimes have a value that you'll say it doesn't converge. And calculating out. And calculating out, we end up with this series will converge at 2. Now, we've looked at arithmetic and geometric sequences, but that's not the only type of sequence that you'll see. Sometimes you have to be a little bit creative. So in here, these are some of the clues that you might use. And you'll have to be, like I said, creative with how you're going to work out your sequence.